My name is Khadir Khan. You are watching Learn to Grow, and today we are with the topic Supermesh. Here we here we have a circuit who have both current and voltage sources. Okay, you can see that it has both current and voltage sources. We cannot simply solve them by simple mesh or nodal analysis. Circuit which contains both current and voltage sources are solved by either nodal analysis or mesh analysis, super mesh analysis. The supernode cases in which the voltage source in between two non-reference points, as we have discussed earlier, was the case of supernode. And here, if we have a current source which is in between, the circuit, okay. So this is a super mesh case. It has two parts. First part belongs to KVL, and the second part belongs to KCL. Okay. First, we will consider the voltage source and we will ignore the current source. Okay, so we will simply open the circuit from the current source. Okay, when we ignore a voltage source, we short that source, and when we ignore a current source, we open that source. But how we will open this source? We will simply open it like this. Okay, so now we have successfully opened this. This is how it will be opened. Okay, I'll removing it back. Here we will apply KVL first. Okay, so in KVL we assign the currents first. Let's say that I1 is flowing in this direction from this mesh. Okay, and I2 is flowing from this mesh in this direction, and I3 is flowing in this direction from this mesh. Okay, in supermesh case, I have said earlier that we open the circuit from the current source. So we will open it like this. I successfully opened the circuit, and this whole mesh is called a super mesh. After opening, this whole mesh is called a super mesh, and this is a simple mesh. So this becomes a super mesh case. Okay, applying KCL, sorry, KVL on super mesh SM. Okay, so we will take all the things according to the current. The current will not mix up. Okay, only the circuit has opened. So according to direction, here minus sign becomes first. This whole is a mesh, a loop. Minus, okay, minus 6 first. Then this is in loop mesh 1 at that time. So 2 I1. Okay, then we will proceed toward this, and this was our second mesh at that time, but this is now the whole super mesh. So we will we will accommodate all these things into a single equation. So here, sorry, you can see here that this 2 ohm resistor is not only in this mesh, this is also sharing this current too. So because we are talking from this mesh we will take I1 first and I3 second. It is sharing both, so minus I3. Okay, like this. Simple, quite simple. Then we will proceed to our 4, and this is sharing both two currents, so this will become 4 I2 minus I3. Okay, this was plus sign. Okay, then this 8 ohm, and this is completely of I2, so 8 I2 is equals to 0 according to KVL. All the voltages which are in a loop or in a mesh has a sum of 0. Now we will simply solve them. Now here you can see I have successfully simplified my first mesh equation. Okay, here you can see that I have three variables in my first equation, I1, I2 and I3. I require two more equations to solve these three variables. Now the second equation will simply come from uh, my this mesh. Okay, so applying KVL on mesh 3, that was okay. So when we apply mesh 3, so we will take it as plus I3 minus I1. Okay, what was that? 2. That was 2 I3 minus I1. Okay, and then this 2 ohm resistor is completely in this wire, and in this wire only I3 current is flowing, so this is 2. Okay, so 2 plus 2 I3 simply. Okay, and then our this resistor of 4 ohm, 4 ohm is in between I3 and I2, so 4 I3 minus I2 is equals to 0 according to KVL, because KVL says the sum of all voltages in a loop or in a mesh has a sum of 0. So I will simplify it. You can see I have successfully now simplified my second equation from mesh 3. Okay, now I have two equations. uh, I have three variables. I require three equations to solve these three variables. So from where will I will get my third equation? I will get my third equation from my second part. My second part belongs to KCL, Kirchhoff's current law, and that will be only applied when I have my current source back. Okay, so I'll back my current source. I have my current source back. Okay, now I will apply KCL on the node, on the nearest node to my current source. So here the nearest node to my current source is this one. Okay, this is the node. Okay, so you can see how many currents are exiting and how many currents are entering. Here this current I2 is entering. Okay, here this is entering, this I2 entering, and this is exiting. Okay, I1 is exiting, I2 is entering, 3 ampere is entering, and this is exiting. So applying KCL on this node, so how many currents are entering and exiting? My 3 is entering, my I2 is entering, and I1 is exiting. Okay, I have got my third equation in terms of I1 and I2. I can now apply two methods to solve my these equations. And do you know what are that methods? That two methods are one from directly you can solve from calculator, okay, from three variable equation, or from matrices. Matrices is a good way to solve these three equations if you don't have a calculator. Okay, you can solve I1, I2, and I3, both three values. If you want me to solve this from matrices, you can ask me in comment box. If you have learned something from this tutorial, like this tutorial and share it with your friends. Don't forget to subscribe Learn to Grow by clicking on the button right there. I'll see you in the next tutorial. Till then, goodbye.